So we are on section 4.2 now, the least squares regression line. There's a big old explanation in here, and there actually was a pretty good formula in 4.1 also. There's a big one in 4.2. I'm not making you do that, guys. You have a calculator, you can use a calculator, okay? There's no sense in you trying to get it to the 8th decimal place and make sure you get things right. I mean, when we tell you to purchase a calculator, you need to be allowed to use a calculator, okay? You do need this little tidbit right here, explanatory variable and outcome variable. The explanatory variable is used to explain or predict the value of the outcome variable. And I think it is, did I actually pick it up? I may not have even done it. It says, nope, I didn't even. That's one of the ones I think I didn't do it all, because it actually says that. It's got the drop downs with the blanks, and it says the blank variable is used to predict the value of the blank variable. And so I was like, okay, no, we're just gonna write that definition because they're just testing a definition, okay? Example 1, the following table represents percentage of students who tested proficient in reading and the percentage who tested proficient in math for 5 randomly selected states in the United States. Compute the least squares regression line for predicting math proficiency from reading proficiency. Okay, now there's a couple important things in here because you got to know who is L1 and who's L2, right? Okay, so it says compute the least squares regression line for predicting. You're predicting math proficiency from reading proficiency. This from reading proficiency, that tells you who's X. So the from part, from becomes L1 or the X value, okay? When they list the table, they should list X first because that is mathematically appropriate to do. I just worry that they might try to trick you. But, I mean, here they do. This is X. This is L1, right? Not Li. I'm sorry, L1. And this is your Y values, L2, okay? So, what they're doing is they want you to do a linear regression that shows how the reading scores, what a child's reading score was, can predict what their math score is. Okay, and there is a link between that. If you have children, some teachers probably told you that in order to do the math tests these days, they got to be able to read. Okay, and it's critical analysis. You got to be able to read it and know what it's talking about. Okay, so we're going to go over here to our calculator, and I'll try to do a split so you guys can see everything. Okay, so I'm just going to clear this. I'm on my home screen, so I need to go stat, and I'm going to edit, right? Okay, let's see. I need to make that smaller. I don't know if it'll let me make it smaller. Hold on. Let me get back out here and make that smaller, or I'm not going to be able to see. Okay, there we go. Now, split view. Okay. All right, I'm going to edit. Remember, you can go up, you can highlight L1, you can hit clear, do not hit delete. I'll have to give you a little transplant if you have to delete, it'll delete all of L1. Did you hit delete? Mm-hmm. Did it delete all of L1? Huh? So what have you been, like you had L1 a while ago, didn't you? Okay.
Oh, it's not the same as delete.
Yeah.
Okay.
Delete will like take the whole L1 column away, and he won't exist anymore. And I have to, you may not have to anymore. You would have to hook him to another calculator and transfer L1 back over to that calculator. But you may not have to anymore. Surely they've come up with something better than Okay, so I've got 73, 73, 79, 75, and 67, right? Then I've got 66, 78, 76, 70, 64. Okay, so I got my L1, L2. I'm going to go to Stat. I'm going to go to Calc. And then I'm going to pick number 4, LinReg AX plus B. Okay. We're going to enter it. We're going to hit enter. X list is in L1. Y list is in L2. Make sure that frequency list is cleared out. We're not necessarily storing it anywhere. I'm going to hit on calculate. And I've produced, now I've produced my linear regression. That's what your y hat is. So we've got y hat equals, now it says round the slope and the y-intercept to 4 decimal places as needed. Okay, so let's have a little recap of who's the slope. The slope is the number with the x. Okay? The y-intercept number by itself. Okay. So when we picked 4, we picked the version AX plus B. Which one of those letters is the slope? Who's with the X? Good. A's my slope there. Okay? And honestly, guys, it really doesn't matter if you remember that for sure. Just make sure you put the right numbers in the right spots. Okay? So you see that A is going with X here. So, and it says round it to 4 decimal places as needed. So I've got 0.9, what is, oh yeah, 9362 X plus 2.0851, right? Okay. Now, you're going to enter that in your homework, and it may come back and tell you, it won't count it wrong, but it may come back and tell you that you could have written it as 2.0851 plus 0.9362x. The same number is still with x, the same number is still by itself, it just switched places, okay? I had, on one question, I had it come back and tell me that, and then when I went and did the rest of the questions, it never warned me again. So it was like, oh, it's kind of like it learned, oh, she wants to do it that way. So I guess, I don't know. It only warned me one time, and I entered it in the first form more than one time. But, okay, number 2. Full screen. Okay, number 2 says, and here's a multi-part one. At the final exam in statistics class, the professor asks each student to indicate how many hours he or she studied for the exam. After grading the exam, the professor computes the least squares regression line for predicting the final exam score from the number of hours studied. The equation of the line is y equals 45 plus 5x. Okay. See how they wrote it the other direction. Okay. The x part's at the end. Antoine studied for 5 hours. What do you predict his exam score will be? What do you think I need to do with that 5? Yep, plug it in for x. So I've got y equals 45 plus 5 times 5. That's going to give me y equals, and you can put that, you can put 45 plus 5 times 5 in your calculator, that's fine. That gives me 45 plus 25. We're getting 70. Okay? He's saying that Antoine will make a 70 because he studied 5 hours. Emma studied for 3 hours longer than Jeremy did. How much higher do you predict Emma's score to be? That's based on what the slope of that line is, okay? So we're going to say this is based on the slope of the line. Okay, so what we have to do is, I'm going to show you how to get that answer real quick first, and then I'm going to prove it to you. Okay, so she studied 3 hours longer than Jeremy did. So if I were to then say, okay, well, that's 3 more that I'm multiplying times 5. What's your slope here? Your slope was 5, right? You take the 5x part, plug in 3. So 5 times 3. We think she'll score 15 points higher. Okay? Now, that's kind of vague and kind of construed. I know that you all can pick out the part with the X and plug it in and you get it, but you don't really know why. So let's say that Jeremy, and so I'll prove it to you here. Let's say that Jeremy studied 2 hours, okay? That means that Emma studied how many? If she studied 3 more, how many did she study? She studied 5 hours, okay? So let's see what Jeremy made with his 2-hour study. We said 45 plus 5 times 2. He's only going to make a 55 because that's 45 plus 10 is a 55. So old Jeremy's going to make a 55. Well, that was Jeremy studying 2 hours. Emma studied 3 more, so she studied 5. So 45 plus 5 times 5. We know that's 45 plus 25 is 70. What is the difference between 70 and 55? 15. Okay? So if you can't remember just to take the slope part, that coefficient and that slope and that x, and plug in the difference in the amount studied. If you can't remember that, you can manually work it out and reason it to yourself. Okay, well, Jeremy studied 2 hours. That means Emma's going to study 3. Let's see what each one of them makes. What's their difference? Okay? All right. Let's keep on going. How many are there? 7. Okay. Example 3. We're going to, it says, select the appropriate word or phrase to complete the sentence. If the least squares regression line has slope B1 equals 3. Okay, so they're telling me that slope is 3. That means I have a 3x. And 2x values differ by 5. The predicted difference in the y values is, okay, guys, this is just like example 2 with was it Justin and Emma, or whoever? Was it Justin? Jeremy, sorry. Jeremy and Emma, okay? You pick out that chunk that has the slope. That's 3x. 3 is your slope. How are your x values differing? By 5. Plug it in. 3 times 5, I get 15. They really shouldn't have used 15 again because that makes you guys think that you're going to get 15 every time. You're not. Okay. Find the slope, plug in the difference. All right, example 4. We want to compute the least squares regression equation for the given data set. We're going to use an 84 calculator, round the slope and y-intercept to at least 4 decimal places. All right. So I'm going to go back over here to my calculator. Come on. There we go. There we go. And I'm going to say, okay, I'm going to go back to stat. I'm going to go to edit. I'm going to clear out L2. I'm going to clear out L1. And my X values, remember my X's go in L1, okay? So this is L1 for me, this is L2. So 6, 2, 4, 10, negative 11, negative 5, 3, negative 13. And then over there with it, make sure they match up, guys. 30, 34, negative 2, 1, negative 4, negative 16. Uh-oh, see, mine didn't match up. Something happened. I left the value off. Or I added an extra 1, 2. Oh, where's my 6? Really? Now I got to retype them all. 4, 10, negative 11, 3. At least it's not as many. Remember in Unit 1, all those we would have to put in there. And we would have to do those frequency table. Oh my gosh. Sometimes y'all were putting like 50 numbers in at a time. 20, 30. Remember that? And we'd be like, oh no, it's 300. No, it's not. It's 485. It was like, how many numbers did we miss? How many numbers did I miss? Okay. So I think I've got mine in there. We want a least squares regression. So I'm going to go now to stat, calc. You can pick 4 or 8, whichever one you want. I'm going to pick 8 this time. It doesn't matter, guys. I'm just going to show you how to do it. See, it asks me all the same questions. L1, L2, frequency list, leave it blank. We want to calculate. They give me the same thing. It's just in a different format, okay? You just have to pay attention to where those numbers go. So I've got y hat equals, this time B is going with X, and it's just because I picked it that way. Told it to report that way. So you could type in 6 point, around the slope, 4 decimal places. 6.4885 plus 1.47. Then I'm going to need to use what? 70x. Okay, you can input it like that, or you can say y hat equals 1.4770x plus 6.4885. Either one of those works, guys. Make sure you put your X on there and make sure you put the X with the correct number. Notice in your picture, we've got B going with X this time, so the 1.4770, I rounded, okay, goes with the X. Okay, example 5. I think it's another regression. What does it say? The following table presents the average price in dollars for a dozen eggs and a gallon of milk for each month from March through December 2009. You answer the following. Compute the least squares regression line for predicting the price of milk from the price of eggs. Okay, so we've got from the price of eggs. So that means my price of eggs is X, right? From the price of eggs, that's my X, that's my L1. So here's L1, so they didn't do me wrong this time. There's my L2, okay? So we're gonna go over here and we're gonna plug, no, don't wanna do that. We're gonna plug it in. Okay, split view. Stat, edit, and go up, clear, enter, up, clear, enter. Okay, let me see what I've got. I've got 1.05, 198.99.05, 0.06, 0.04, 0.08. Okay, let's see if I got them lined up this time. 2.81, 2.82. 2.78, 2.75, 2.72, 2.73, 2.72. No, dadgummit. 2.81, 2.82, 2.78, 2.78, 2.77, 2.75, 2.72, 73. Oh, I just missed a 73. Yay. Not 4. That will make a big difference. Okay. Get them in there. I'm going to go to stat. I'm going to do calc. I can't help it. I'm going back to 4, my old school algebra self. That all looks good. I can calculate, and sure enough, I get y equals, this time a is with my x. Just make sure you pay attention. Negative 0.6959x plus 3.4742. Y'all okay with that? Is that what we got? Okay. That's part 1. Part 2, you're going to use that equation that you have right there. And it says if the price of eggs differs by 25 cents from one month to the next, by how much would you expect the price of milk to differ? Okay, so this is like Jeremy and, was it Emma? Okay, Jeremy and Emma, okay? Let's pick out the part with the slope. Let's pick out the slope. So that's really negative 0.6959 is my slope. We tag that with my x. My slope sits in front of my x, right? Oh, no, we're not doing that here. Differs by 25 cents from one month to the next. Okay, I actually put in values there. And I went from like 1 month it was $1 and the next month it was $1.25. You can still do it this way. I still did it the Jeremy Emma way. It's not going to make a lot of sense to you at first because it's going to be negative. Just plug it in there. Let's see if it'll work Let's see if it'll work okay. So I'm going to say negative 0.6959 times, what, 25 cents? Okay? So I'm going to say negative 0.6959 times 0.25. Yep. Okay? You don't need the negative on there. You just need, it's just showing the difference. It might have been higher, it might have been lower. That's what that negative's showing. But it's how much? 17 cents. So we go, it will differ by 17 cents. Now, here's why we can't get a negative answer, guys. Even though there's a negative answer there, you can't list it as negative. Well, it can be. Is money negative? Technically, no. It's like saying is distance negative. Now, you can, debt is. We can't go there. But it's going, okay, how much did the price differ by? If the price, what it's saying is the price of, who was in L1? Eggs? Yeah. If eggs differed by 25 cents in 1 month, how much should the milk differ by? 17 cents. Now that may be showing that it's 17 cents lower, okay, because it's negative. So it's 17 cents lower than it was the month before, but it's still the difference of 17 cents, okay? 3 says, predict the price of milk in a month when the price of eggs is $1.77. Actually, they should have asked this first. It's nicer. So I'm going to take my whole formula because I want the price of milk, and eggs was X, right? Eggs was my X part, yeah. So I'm going to take my formula. Y hat equals, I'm going to go back over there, negative 0.6959x plus 3.4742. And I'm going to plug in, how much were the eggs? $1.77 that month. I'm going to put in 1.77 for my X. That's the price of my eggs. And I'm going to predict how much my milk's going to cost. Okay. So I'm going to go back over here to my calculator. I'm going to split my screen so I can see because I don't have it written down over here. I just put an answer. That's so smart of me. I've got negative 0.6959 times $1.77 plus 3.4742. Right? Yep. So we're predicting that the cost of milk. We're predicting that the cost of milk is $2.24. The month that eggs is $1.77. Okay. Okay, then I jumped around. I think this does not correlate to number 6, I don't think. I got bored and I jumped over like to question 11. I think that's what happened. Maybe. Or maybe that's actually example 7 is where I got bored and jumped to 11. Okay, which of the graphs below shows the most reasonable line of best fit for the given scatter plots? Guys, this is pretty much an eyeball thing, okay? Which one of those lines matches the best with its data? You know it's not C. Okay, we know it's not C. Get rid of that. You know it's not B. Look at him sticking. He's way down there and his points are up high. So, the ones in question are A and D. Okay? And the easiest way to pick that, guys, is you kind of go, okay, they both have that outlier that's way down there, okay? But he's in the same spot. And if I'd made you do the formula, you would have calculated that space in between there, and then you would have squared it, and you could have calculated how far off he was. But looking at it, the amount that outlier in A is off looks about the same as D, right? It's about this distance. Here's what I'm talking about. The distance from here looks about the same as the distance from there, okay? So what we need to look at is kind of which one has kind of the most points on the line the closest then? D. So your answer is D. Yeah. Okay, example 7. Oh, no, example 7 is where I went to number 11. Yeah. Okay. Or 10 or whatever. I guess maybe it's 10. I didn't do 7, 8, 9, but I said I did. Maybe there were only 11. Were there only? Yeah. We're back. Example 7's the last one, right? Okay. Y'all are like, yes, get done. Look, we can leave an hour early. Example 7. You and me both. Interpreting technology. Okay, so they're showing you the picture. You'll notice that they picked number 8 because it's y equals a plus bx. This is why they prefer you to do that one. It's just hard for me to go, oh, pick 8. All right, so they're asking you questions about what you got for an answer on the calculator, and they gave you that. So it says, write the equation of the least squares regression line, use full accuracy. Well, you know how to do this, guys. Oh, this one says use the full accuracy shown in the calculator output. So you got to write, you have to type all the decimals out that it shows you. So this is going to be y hat equals 2.21, because it starts off with a. It says a plus bx, so a is 2.210555209. Yep, you got to write the whole thing on this one. All because he says do not round your answers. Yep. Plus, hold on, I had a little weird mark up there. Okay, plus 0.324887x. Guys, all they're trying to do is see if you can read a calculator. Yes, you can. Okay, what is the correlation between the interest rate and the yield of the stock? Okay, and you're like, we didn't talk about that. Yeah, we did. What is it asking for? The correlation coefficient. That's R, guys. Correlation coefficient is R. And so you would list 0.67591135. That's your correlation coefficient. Once again, you've not done any math. All you're doing is copying down some numbers from a screen. And 3 says predict the price when the prime interest rate is 5.5%. Round the answer to at least 4 decimal places. I'm going to warn you on here. Don't convert that percent to a decimal. Okay, because when I first worked it, I was like, what's that? What we always do? Oh, it's a percent. I got to turn it into a decimal so I can work with it. Evidently, when they made this table, when they input their table, they did not do that. They used 5.5 because I worked some other problem and yeah, I got it wrong. Okay, so don't change percent to decimal on this particular type of question. Okay, it's just pretty much in this homework assignment in this section 4.2 on these questions. Okay, so if we want to predict the price, we're going to take our big long y equals 2.21 blah 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 blah, and we're going to put 5.5 in for x. Okay, so I'm going to write it. You start typing it in the calculator. I got y hat is 2.21055209 plus 0.324887 times 5.5. And that will give me, what'd y'all get? To 4 decimal places.
3.9974.
Yep, that's exactly right. 3.9774. And that is all of 4.2.